All right, so example 6, last example. It's a compound fraction. So compound fractions are when you have fractions inside fractions, which ultimately you would never leave it that way. So it's considered unsimplified when you have a fraction inside a fraction. So we need to simplify this. There are two methods to do this. So I'm going to go through both, and then you'll have one try. All right, so method 1, find the least common multiple of the fractions in the numerator and denominator. So like the least common multiple between every fraction. So between the denominators of x, x plus 1, and y, the least common multiple would be x times x plus 1 times y. And you multiply that by numerator and denominator. And what you end up with once you multiply is, and then collect like terms, is that. So you're going to end up with 3x plus 1 times y over x times x plus 1. For being perfectly honest, I completely prefer method 2. So let's take a look at what that is. So here's where you would just simplify the numerator and the denominator separately. The denominator here is just one fraction, so you're not going to touch that. So in this case, we're just going to find the least common multiple between the two fractions in the numerator, which would be x times x plus 1. So the first fraction, you need to multiply numerator and denominator by an x plus 1. The second fraction, you need to multiply by x over x. And then once you have that numerator simplified, you're going to multiply by the reciprocal of the denominator instead of dividing by the fraction, right? When you multiply across, and you end up with the same answer you got in method 1. And like I said, I'm doing method 2 when I do the you try it questions. You can do either method. If you prefer method 1, that's great. I just learned it with method 2, so that's what I'm going to do. So why don't you pause it, give these a try, and then come back and check. So in part A, in the green here, I'm just working with the denominator. In the first fraction, the least common denominator would be 3 times x minus 1. So in the first fraction, I'm multiplying numerator and denominator by the x minus 1. In the second fraction, I'm multiplying numerator and denominator by 3. Right? X plus 1 times x minus 1 is a difference of squares, so it ends up being x squared minus 1. 4 times 3 is 12. So the negative 1 plus 12 is how I got that 11. And then 3 times x minus 1 is 3x minus 3, although it became apparent when I did the next step that I wrote it back as 3 times x minus 1, because now when I'm doing the numerator divided by the denominator, instead I wrote it in blue here as the numerator multiplied by the reciprocal of the denominator that I got in green there. The x minus 1s cancel out, and what you're left with is 3 divided by x squared plus 11. Right, down here in part B, I simplified numerator and denominator separately. The 2 needed to be over denominator of x, so I multiplied numerator and denominator by x and ended up with 2x minus 1 over x. In the denominator, that x needed to be over x, so it's x squared over x plus 2 over x, so you end up with x squared plus 2 over x. A fraction divided by a fraction is the same thing as that fraction multiplied by the reciprocal. So the denominator just became the reciprocal, and now multiplying, the x's cancel out, and what you're left with is 2x minus 1 over x squared plus 2. All right, let me know if you have any other questions. Give the exit ticket a try, and we will go over all this tomorrow.